Good morning one and all. My course is computer architecture and the topic is operational concepts. The objective is to understand the interface between the memory and the processor, and as an outcome the students will be able to gain the knowledge of how the communication is taking place between the memory and the processor. So now let's see what are the topics to be covered. Definition of instruction, the types of instruction, how an instruction is getting executed, next the connections between processor and the memory, and finally we'll deal about what are the steps to execute an instruction. So now let's have a reflection spot here. So basically everybody knows how a computer works. So can you pause this video for 1 minute and answer the question? So I hope you all would have thought for this question for this reflections part. So the answer is, a computer is a machine and this machine should have some input to work. So an input will be in the form of an instruction. So basically this computer will not be working unless we provide the input as an instruction. Next, a computer system works in a following way. First, initially, the user will give an instruction, and once the instruction is given by the user, a computer will be executing the instruction, and when he executes an instruction, he'll be executing a program. A program is nothing but which contains a bunch of instructions, and only when this bunch of instructions are executed, a particular task for which the user gives the input will be achieved. John von Neumann is a mathematician. He supplied a number of instructions. Okay, instead of supplying a single instruction, what they were doing in ancient days is they were supplying one instruction, they were waiting for it to be processed until they get the output, and next they will be giving the next instruction. Instead of this, von Neumann, what he did is he proposed a concept of supplying a bunch of instructions instead of supplying the instructions one by one. Next, how an instruction is located in the memory, that thing we'll see in detail. Memory location and addresses. Every memory consists of millions of storage cells, and each cell will be having a bit of information. As all know, the bits will be in the form of zeros and ones, and it will not just be a single bit, it will be in a group of bits, and this group of bit is called as word, and the word has a length, and that length varies from 8 bits to 64 bits. And to access a particular, as I said, memory consists of millions of storage cells, and each cell should have some address for accessing. Only inside that particular cell the instruction will be stored, and to access the particular instruction in a particular cell, we should give its own address. Next, let us see the three concepts of von Neumann architecture. The first concept he proposed is data and instructions. See, this is a von Neumann architecture. Here, data and instructions both are stored separately, but inside the same memory location. First, what happened is, first they will be calling the instruction in a single instruction. First, only the instructions will be fetched, and next they have to send another instruction to fetch the data. Whereas using von Neumann architecture, using a single instruction, they can fetch both the instruction and the data. That is the first concept he proposed. And the next concept is, instruction will be having its own memory location. As I said before, every instruction need to be accessed, so it should have its own address. So to access a particular instruction, every instruction will be given a specific address. It will be unique. And the third concept is, the instructions will be executed in a sequential manner unless they are given explicitly. So till they are given explicitly, every instructions will be executed in a sequential manner, one after the another. And now let us see an operational concept analogy. So here a cookbook is compared to a chef is compared to the computer processor. So what a chef does is, he'll be following the instruction from the instruction book, and he'll be cooking his own product, that is processing, and then finally he'll be keeping it in the store. Similarly, a computer instruction will be the input, which is compared to the cookbook, and the computer processor is compared to the chef, where once the computer gets the instruction, the processor processes it, and once the processor processes it, the final output will be kept in the data memory. This is a simple analogy. Next, let us see in detail of how an instruction is working and what is an instruction. So instructions are the commands, and this commands governs the transfer of information within a computer, not only within the computer but also between the computer and the input and output device. And they also specify the arithmetic and the logical operations, which these two operations are the very important operations that have to be performed, because every instruction has got basically some arithmetic and logical operations, and so this instruction is responsible for performing these operations, and it is made up of two parts. One is the operational code, and this operational code specifies the particular operation which has to be performed, and address part is nothing but the address of the operands for which the operation is specified. And next is an instruction example. Add #45 is an example for instruction. Add is the opcode, whereas hash is nothing but the addressing mode. Addressing mode we'll be seeing in the later topics. So addressing mode is nothing but it specifies how an operand is there in the memory location. And this 45 is the operand. Actually here we will be having the address, and it has gone to the address and fetched this 45 value. That is why here 45 is the value that is given here. And next, there are three types of instructions. The first thing is 3-address instruction. The three types are 3-address instruction, 2-address and 1-address instruction. The three types of instructions are the memory of. In the 3-address instruction, three operands will be involved. For 2 source operands and 1 will be the destination operand. The source operands are here add. Example, if we take add R1, R2 and R3. So the micro operation that is taking place is R1 will be storing the destination value after adding the value of R2 and R3. So R2 and R3 are added up and it is given in R1. So if we take an example of x is equal to a plus b into c plus d, how will you write an instruction? So we have to write the instruction like first a and b will be added and it will be placed in the register R1. Similarly, c and d will be added and it will be placed in the register R2. Finally, both the R1 value and R2 value will be multiplied and it will be placed in the register X. This is the 3-address instruction where 3 registers are involved. Here R1, R2 and X are the registers that are involved. Next, 2-address instruction. 2-address instruction here two things are involved. One will be source and the other will be destination. Example is add R1, R2. Here R1 is a thing which will be acting as a source and also as a destination. So R1 and R2 is added up and it is again placed in R1. So in this same example, to write a 2-address instruction, x is equal to a plus b into c plus d. We are moving R1 value of x to R1, and we are adding up this a value which is placed in R1 with b, and again we are doing the same thing to c. C is moved to R2 and this R2 is added with d. So this a plus b is placed in R1 and similarly c plus d is placed in R2. The same way here multiplying this R1 and R2 and we are placing it in R1, and finally this R1 is again moved to the memory location X. Now let us see the last type of instruction, 1-address instruction. Here only one register will be involved, that will be either a source or a destination. So it needed another register to perform an operation. Here it will be using accumulator for all the data manipulations. Example, add x. So x is the value which is added with the value of accumulator, and finally it is placed in accumulators. Now if we take this, evaluate x is equal to a plus b into c plus d, how will we write an instruction? Instruction is written in the way like we are loading the value of a into accumulator and we are adding the accumulator value with b. Similarly, we need the accumulator to perform the operation of c plus d. So what you have to do this, accumulator is already having the value of a plus b. So this memory register temporary register accumulator value is moved. Again, C plus D operation is performed and moved to the accumulator. Now the temporary register value is added with accumulator, and finally the value is multiplied and moved into the accumulator, and accumulator value is moved to X. Now let us have a reflection spot of the load and store operations. So what is load and what is store? Anybody is having an idea? Can you think for a minute? So basically loading operation is the thing which is performed before we perform some operation. So to perform an operation we need a value. So that value is loaded from the memory into the processor, that is load. Similarly, store is the thing which is performed after the execution of a particular operation. Here, what is happening is once we are after getting the value loaded, we have the value and that value is processed, and after processing that value need to be stored into the memory location again, the end output. So that time this store is used. That is the difference between this load and store. Let us see in detail. So to perform a load and store operation, what we have to do is basically we need an address. To load a address, we need the location from the memory where the value has to be loaded from. Similarly, to store an operation, we need to know the address where the value need to be stored into the memory. And the control signals are there, read and write signals. And these are the two operations, load and store, as we have discussed. Now let us see in detail of load and store. So load operation is the one which has the contents from the main memory into the register. So only into the register the process is taking place, and here the memory contents will not be changed. So the step is, first the processor will be sending the address and the read signal, and once the read signal is issued, it will go into the memory and it will be reading the particular value which is loaded from the memory into the processor. This is load operation. Similarly, in the store operation, it will be transferring the information, that is the word, along with the address part and along with the write control signal. Here what will happen is, when it writes a word, the contents in the memory will be replaced. This is the store operation. Now let us see an example of instructions. Here, add location A. What is happening here is, the memory location A value will be fetched and then it will be added up in R0. Similarly, the memory location A will be loaded and it will be moved to the register. In second example, it will be moved to the register R1, and finally R1 will be added up with R0 and the value will be stored in R0. These two are the examples of two address instructions. Now let us see how the connection is taking place between processor and memory. So this is main memory and this is the processor. These are the contents in the processor. Program counter, IR is the instruction register, control unit, and logic, arithmetic and logical unit, and this processor memory interface is the interface that connects main memory and the processor. So what is happening is, program counter initially has the address of the next instruction that has to be executed. So the program counter will give the address, and that address will be gone into the through this memory address register. This memory address register contains the address of each and every memory location. So through the PC fetches the address, passes the address of the next process through the memory address register, and it finds the value and it is given into the memory data register, and this memory data register process, after getting this, it will be passing into the decoded information into the instruction register. So similarly, it performs the operations also. So first the instruction will be loaded and it will be given to the arithmetic and logical unit. The arithmetic and logical unit has some operands that has to be fetched from the main memory. So again it gives the value into the memory address register, and it will be fetched and it will be given to the memory data register, and from the memory data register it will be given into the arithmetic and logical unit. Similarly, every operands will be fetched, and whatever operations need to be performed, every operations will be performed by the arithmetic and the logical unit. This is the way how the instruction is getting executed. Nothing but the memory address register will be fetching the address and will be giving into the memory data register, and this memory data register contains the processes and give this to the arithmetic and the logical unit.